Good day, everyone. Today we are going to discuss about functions. Okay, so let us discuss first the definition of function. A function is a relation or a set of ordered pairs in which no two ordered pairs have the same first coordinate and different second coordinates. Okay, so if we recall, we already discussed about relation, and it is a set of ordered pairs. Now this time, let us see if this relation is a function. So for example, we have a set of ordered pairs. Let's say 2, 3, 1, 6, 5, 2, we have 2, 8. Okay. Now, let us determine, this one. Now, let us determine if this relation is a function or not. Now, let us examine every ordered pair that we have. So, this ordered pair 2 and 3, so meaning 2 is paired with 3, 1 and 6, 1 is paired with 6, 5 and 2, 5 is paired with 2, and 2 and 8, 2 is paired with 8. Now, in this example, this relation cannot be considered as function because it violates the definition. Why? Because we have two ordered pairs, this one, 2 and 3 and 2 and 8. Okay? The ordered pairs 2 and 3 and 2 and 8, the first coordinate 2 has two corresponding y coordinates. So they are different. The y coordinate or the second coordinate 3 and 8, they are different, and it really violates the definition of a function that no two ordered pairs have the same first coordinate and different second coordinates. And in this case, we have two ordered pairs with same first coordinate and different second coordinates. So this example, this relation is not a function. Okay, so let's move on to the next slide. To the next item. So as you can see this diagram, we have two sets, set A and set B. Now set A has elements, element X, point A, and this point. Now if you're going to look at this diagram, every element in the set A is what we call the domain, and set B is what we call the range. Every element in the set A has only one corresponding element in set B. Take for example point X. The corresponding element in set B is denoted by f of x, and A is has a corresponding element in set B, which is f of A, and this point has only one corresponding element in set B. Okay, so again, a function f from a set A to set B, okay, from set A to set B is a relation that assigns to each element x in the set A exactly one element y in the set B, and that is actually the definition of a function. To the set A again is what we call the domain, and the set B is what we call the range or the set of outputs. Okay, so take note of the definition of function. Now, to understand more on the definition of function, we can also think a function like a machine. So a function is like a machine. Okay, it has an input and it has an output. So let us look at this diagram. Suppose this is a machine. So we have here the variable x as the input variable, and the output variable denoted by f of x, and usually we denote f of x to be the y variable. Now this x here, x, is what we call the independent variable. Independent variable. Okay, while this f of x here, this is what we call the dependent variable. And usually f of x is denoted by y. Okay? Again, we think a function like a machine. We have a set of inputs and then we also have set of outputs. Now this time, let us determine which of the following illustrations are functions or just a relation. Okay, is the first diagram in letter A can be considered as function or is just a relation? How about in letter B? Is this a function or just a relation? How about letter C? Is this a function or a relation? How about letter D? Is this a function or a relation? Now let us examine the diagram one by one. Let's start with the letter A. Now the question is the set of ordered pairs. Actually, we only have one ordered pair here. B is paired with U. Now the question is this a function or just a relation? This is not a function. Now, what makes this diagram violates the definition of function? Because of this element G. Why? Because this element G has no corresponding element in the set B. Because by definition of function, every element in the set A has only one element in the set B. How about letter B? Is this a function? Still not a function. And what makes it not a function? Because of the element G. Because by definition, every element in the domain has exactly one element in the range. But in this case, point G has two different corresponding elements in the set B, the point T and point Z. How about letter C? Is this a function or not? This is a function because it satisfies the definition of function that every element in the domain, the element B and element G, have exactly one corresponding elements in the range B. How about this letter D? Is this a function? Yes, this is a function because every element in the domain has exactly one element in the range. Okay, so let's move on to the next slide. Another example. So we recall when we discussed the topic relation, we had this example. Okay, now this ordered pair, set of ordered pairs is a relation. Now actually, this is a set of ordered pairs that relates the terms even and odd to the first 5 natural numbers. So meaning to say the word even and odd relates or they are mapped to the first 5 natural numbers. So let us look at the first ordered pair. Let's say the term odd is mapped or is paired with the natural number 1. The term even is paired with the natural number 2. The term odd again is paired with the natural number 3. And the term even is paired with the natural number 4. And the term odd again is paired with the natural number 5. So if we are asked, what is the domain of this relation? The domain is the set of the terms odd and even. Okay, how about the range of this relation? The range is the set of the first natural numbers, the first 5 natural numbers. 1, 2, 3, 4, and 5. Okay? Now, if we are asked, is this a function? Is the relation a function or not? Now, each element in the domain, notice the even and odd is not paired with exactly one element in the range, right? Because the range composes of 1, 2, 3, 4, and 5. Okay? Take note, each element in the domain, even and odd, is not paired with exactly one element in the range. For example, let us look at this one. Odd is paired with 1. But again, in this ordered pair, odd is paired again with natural number 3. And this one, odd is paired with natural number 5. So we have 3 ordered pairs, okay, having the same first coordinate, but they are having different second coordinates, and that violate the definition of function. Okay, so therefore the relation is just a relation but not a function. Okay, so another example. Example, we have set of inputs, the elements are P, Q, and R, and we have the set of outputs, the elements are M and N. Now, if you are going to look at the elements in the set of inputs or in the domain, every element has corresponding one element in the set of outputs. That's why this is a relation which is also a function. In the second example, as you can see, every element in the set of inputs has corresponding one element in the set of outputs. And as you can see, this is a one-to-one function. Okay? How about this one? Now, this is not a function because we have point Q, okay, with different two corresponding elements in the set of outputs. So this violates the definition of a function. Okay? Okay, another example. Determine if the menu price lists are functions or not. Okay? In the example, first example in figure 1, we are going to determine if the price lists are functions or not, are functions of the item or not. So here's the problem. The coffee shop menu shown in figure 1, okay, consists of items and their prices. As you can see, the menu shown in this figure 1 consists of item and price list. The items are plain donut, jelly donut, and chocolate donut. Notice that the plain donut has a price of 1.49, the jelly donut has a price of 1.99, and chocolate donut has a price of 1.99 again. Now the question is, for letter A, for this figure, is price, okay, is price a function of the item? How can we answer that one? Okay, so let us go back to the definition of function. Now, is price a function of the item? By definition of function, it must satisfy the condition that for every element in the domain has exactly only one element in the range. Okay. Now, is the item or a function of the price? Now, in figure 2, we are asked, is the item a function, this one, a function of the price? Okay, so we answer this problem one by one. Okay? So for our solution, okay, so let us try to look at the first menu. We have item. The plain donut has a price of 1.49. Also, the jelly donut has a price of 1.99. Chocolate donut has a price of 1.99. Now, if we are going to relate this one to the definition of function, this item here, set of item, we consider this as the input or the set of inputs. While in this side, the price or the price list, we consider this as the set of outputs or output. Okay. Now the question. Now take note that the plain donut is mapped with the price 1.49. Okay. While the jelly donut is mapped with the price of 1.99. And also the chocolate donut is mapped with the price 1.99. So what do you think? Is the price a function of the item? What do you think is the answer? The answer is, note, each item on the menu has only one price. So the price is a function of the item. Okay? Because every item has only one price. This one, and this one. So therefore, we can say that the price is a function of the item. Okay? Now for number 2. Now the plain donut. So the question is the price a function of the item? Okay? So how can we answer this one? Again, first, we have to take note that the set of item is the input or the set of input values or input items, while the price list is the set of output. Okay, now since the question is the item a function of a price? Now let us try to look at the price lists. Now for every price list, the question is the price list, for example, 1.49 is mapped only with the item here in the first part of this menu, the list of items. Yes, 1.49 has only one corresponding item, which is plain donut. Okay. Now, how about this one? The jelly donut at the price 1.99. Now, take note the price 1.99 is paired with two items, the jelly donut and the chocolate donut. So, what do you think is the answer? Is the item a function of a price? What do you think? Not all prices in the menu has only one item. So the item is not a function of the price. Okay? So here are the important remarks. We have to remember this. Function from set A to set B. First, each element in A, where A is the domain, must be matched with an element in B. So for a relation or a set of ordered pairs to be considered as function, this must be satisfied, that every element or each element in the domain A must be matched with an element in B. Next, some elements in B, you notice in the previous examples, that may not be matched with any element in A. Okay? Did you recall that there are elements in B with no corresponding elements in A in the domain? Because if we are going to look at the definition, we must have to look at always the domain. Okay? Now, another is two or more elements in the domain A. So, two or more elements in the domain A may be matched with the same element in B. There was an example in the previous slide that the two elements in A has only has or share the same element in B. So that's why that relation or set of ordered pairs is also considered as function. Now, how about this one? An element in A in the domain cannot be matched with two different elements in B. So these are the important remarks, important things to remember for us to say that a relation or a set of ordered pairs is a function. Okay? Okay, so thank you so much. I hope that you learned something from this video, and I'm also encouraging you to share the learning that you got from this video. Okay, so thank you, and once again, if you have questions, you can just post your questions in the comment section where this video is uploaded. Okay, or you can email me if you have questions or clarifications. Once again, thank you very much and God bless.